Hello, precious one. I welcome you once again into Kenya Ako Mathematics Classroom. On this platform, I'll be teaching you elective mathematics and commerce. But on this particular episode, I'll be teaching you rational functions. Now, we are going to look at what we call rational functions. And when we talk about rational function in general is division of two polynomials or the ratio of two polynomials. So when you divide one polynomial by the other, what you are getting is what we call the rational function. Now, I advise that if you have not watched my presentation on polynomial functions, then you enter Kenya Ako Mathematics Classroom on YouTube, watch the video on polynomial functions so that you can appreciate what we are going to do on rational functions. So in general, we are saying that rational functions is the division of two polynomials. Now let's assume that we have f of x equals g of x over h of x, where g of x and h of x are polynomial functions. They are polynomial functions. And h of x should not be equal to 0. So when you consider the rational function, if f of x equals g of x over h of x, g of x and h of x are all polynomial functions. So because we are dividing one polynomial function by the other, what we have is what we call the rational function. So in this case, the rational function is the f of x. Take note that you are saying that the h of x must not be equal to 0, because if the h of x is equal to 0, then the rational function is not defined. And therefore, for g of x over h of x to be a rational function, then the denominator or the h of x should not be equal to 0. So when we divide one polynomial by the other, what we have is what we call the rational function. Now, with the rational functions, we have the proper rational functions and we have the improper rational functions. And what is really happening is, let's assume that we have f of x to be equal to, we have 5x squared plus 7. Then we have s cubed minus 12x plus 4. When you look at this rational function, realize that with the expression we have up there, the degree of the expression is 2. When we talk about the degree, the highest exponent of the variable in the expression is what we call the degree. So the highest exponent is 2. That means that here the degree is 2. Now when you look at the denominator, the highest exponent is 3. So the degree is 3. So you can see that the degree of the numerator is 2, but the degree of the denominator is 3. So 2 over 3, because the numerator is less than that of the denominator, we say that this particular rational function is a proper rational function. So take note that for it to be a proper rational function, then it means that the degree of the numerator must be less than the degree of the denominator function. So let's take note of that. The degree of the numerator, when it's equal to the degree of the denominator, then we say that rational function is a proper rational function. Now, assuming that we have f of x to be equal to, we rather have s cubed minus 12x over s squared plus 2. If you look at this rational function, this is a rational function because it's a division of two polynomials. This is a polynomial, this is a polynomial. Then because we are dividing one by the other, what we have is what we call the rational function. That's what we are looking at. So when you look at the numerator, the degree or the highest exponent of the variable is 3. You can see that. And that of the denominator is 2. So you can see that the numerator is bigger than the denominator in terms of the degree. So this is an improper rational function. Now, let's assume that we have s cubed minus 12x over, then we have x squared plus 2, but we have another expression, that is x plus 1. When you look at this, realize that the degree of the numerator is 3. You can see that is the highest exponent. But when you look at this, when you check the two brackets, here we have a quadratic expression, this is a linear expression. When we expand, take note that the highest degree will also be 3, because we have s squared here, we have x here. So one of the term will be in s cubed term, and therefore the degree of the denominator is also 3. Now, when it happens like this, this is also called an improper rational function. So take note that for a rational function to be improper, then the degree of the numerator must be equal to, either is equal to or greater than the degree of the denominator. And I guess you understand what we are talking about. So when the degree of the numerator is equal or greater than the degree of the denominator, then that rational function is an improper rational function. But when the degree of the numerator is less than the degree of the denominator, then we say that rational function is a proper rational function. So in general, when we talk about rational functions, it is just division of two polynomials. Division of two polynomials. Now, we are going to look at operations on rational functions. And then with the operations on rational functions, what we are going to talk about is the addition of rational functions, subtraction of rational functions, multiplication and division of rational functions. That's what we are going to look at. So let's assume that, so we have what we call the operation on rational function. Now, in general, you know what we call a rational function. So we are saying that a rational function is the division of two polynomials. So we have to look at that. Now we are looking at operations on rational functions. And with operations, we are talking about addition, subtraction, multiplication, and division of rational functions. So let's assume that we are given this rational function. We have f of x. This is equal to, we have 5 over, we have x plus 2. And g of x is equal to, we have 7x over x squared plus 2. Then let's assume that we have h of x to be equal to 2x plus 1. Then over we have 3x minus 2. So if this is what we have, let's assume that we have these three functions. Now, assuming that we are asked to find I, f of x plus g of x, I, f of x minus h of x. And we are also asked to find g of x dot h of x. That means we are talking about multiplication. Okay, so then let's say IV, the fourth part of the question, we have to find g of x divided by h of x. Okay, so we are going to look at the operations on rational functions, how we can add rational functions together, how we can subtract, how we can multiply, and how we can divide rational functions together. Now, the first question, don't forget that we are given f of x to be equal to 5 over x plus 2, g of x to be 7x over x squared plus 2, h of x to be equal to 2x plus 1 over 3x minus 2, and we have to find f of x plus g of x. That's the first question. So we have to find f of x plus g of x. Now the f of x function is 5 over x plus 2. Now plus, because we are adding to g of x, that is 7x over x squared plus 2. So when we are adding two rational functions, what we do is we try to find the LCM, or the common denominator. Now this is going to be x plus 2, and this is x squared plus 2. So to simplify this here, we are left with this. So this will multiply the numerator. That is 5 times, we have x squared plus 2. Then plus this into this, we are left with this. So this will also multiply 7x. So 7x will multiply x plus 2. And this will be equal to 5 times x squared will give us 5x squared. 5 times 2 will give us 10. Then 7x times x will give us 7x squared. According to the law of indices, and I guess you understand that. Then plus 7x times 2 will give us 14x. All divided by our denominator, that is x plus 2. Then we have x squared plus 2. So we simplify the numerator. We add the like terms together. So we have an x squared term here, another x squared term here. So 5x squared plus 7x squared will give us 12x squared. So we have 12x squared. Then the only x term we have here is 14x. And the only constant we have here is 10. So all divided by the denominator is still x plus 2, then x squared plus 2. So when we are asked to find f of x plus g of x, this is the result. So that's what we do. So with the addition of rational functions, we find the common denominator, or the least, the LCM. So that in doing that, and I guess you understand what we are talking about, because when we are given two fractions to add, we find the LCM and simplify, and it's the same thing we are talking about here. So this we have 5 over x plus 2 plus 7x over x squared plus 2. So the least denominator or the least common multiple, the LCM, will be x plus 2 then x squared plus 2. So we have this, and now this here we are left with this. That means this comes to cancel this, and we are left with this, and this will be multiplied by the numerator. And that's how come we have 5 times x squared plus 2. Then plus this will cross out this, and we are left with this. And this will be used to multiply the numerator of that expression. So we have 7x times x plus 2. Then 5 times x squared, 5x squared, plus 5 times 2 is 10. Plus 7x times x is 7x squared. Then 7x times 2 is 14x. Then we simplify. Take note that the numerator should be divided by the x plus 2, x squared plus 2. So we simplify by adding the like terms. We have an x squared term here, x squared term here. So 5x squared plus 7x squared will give us 12x squared. That's the 12x squared we have here. The only x that we have is 14x. So we have 14x plus the only constant is 10. So we have plus 10. Now all divided by x plus 2, x squared plus 2. So that is how we add rational functions together. So let's see how best we can solve. And I guess you understand what we have on the board. If you are a little bit confused, I would advise that you pause the video, you take it back, you take your time, get your book, get your pen, get your calculator, and begin to do the practical work yourself so that you can understand. If there is any question you have, you can leave your question in the comment section. I will solve it on this same particular platform. Now we are going to look at the second question. The second question, and don't forget that with the second question is subtraction. So we are looking at operations on rational functions. So the second question is f of x minus h of x. It is not g of x. So it is f of x minus, take note, the second question is f of x minus h of x. So minus h of x. Now f of x, the function, we have 5 over x plus 2 minus h of x. H of x is 2x plus 1 on 3x minus 2. That is 3x minus 2. So we still find the common denominator, and that is x plus 2. Then we have 3x minus 2. Okay, so this here we are left with this, and I guess by now you understand that. So this crosses out this, and we are left with this. So this will multiply 5. So we have 5 times 3x minus 2. Then minus this here, we are left with this. So this will also multiply this. So we make sure we keep them in brackets so that it will not affect our answer. Okay, so this is what we have. Now we simplify. 5 times 3x will give us 15x. 5 times minus 2 is minus 10. Then let's simplify this. 2x will multiply x, and that will give us 2x squared. 2x times 2, this will give us 4x. Then 1 times x will give us x. Then 1 times 2 will give us plus 2. So we are done with that. All divided by x plus 2, then 3x minus 2. Okay, so this will be equal to, we simplify. Now we have 15x here minus 10. Then we simplify what we have in the bracket before we open the bracket. So here we are going to have 2x squared. Then 4x plus x will give us 5x. Take note that the constant coefficient of this x is 1, but 1x is the same as x. That's why it cannot be seen. So 4x plus x will give us 5x, then plus our constant, that is 2, all divided by the same denominator expression, x plus 2, then 3x minus 2. So we simplify by opening the brackets. We have to simplify by opening the brackets. Okay, so now, because I don't want to get the question off the board, I think I will continue it here. So this will be equal to, now we have 15x minus 10x, then minus 2x squared minus 5x minus 2. Okay, so minus 2x squared minus 5x, then minus 2. All divided by the same denominator, x plus 2, then 3x minus 2. Okay, so we simplify the top by looking at the like term. The only x squared term we have is minus 2. So minus 2x squared. Then the x term, we have 15x here. We have 5 minus 5x here. So 15x minus 5x will give us 10x. So we have plus 10x. Then we look at the constant. The only constant we have is minus 2. So we have minus 2. All divided by, we have x plus 2, then 3x minus 2. So this will be the expression for f of x minus h of x. So it's the same thing. We find the least denominator, the least common denominator, the LCM, the least common denominator. Then we simplify like how we solve fractions. That's subtraction of fractions. And this is what we have. So take note of that. Take note of that. Now we are going to look at how best we can solve the third part of the question. Once again, I advise that if you are a little bit confused what you have on the board, you pause your video, take your time, take the video back, listen to what I'm saying, then you will get exactly what you have on the board. So now we continue with g of x dot h of x. G of x dot h of x. So now we simplify g of x dot h of x. Okay, so the third question, we are asked to find g of x dot h of x. Now g of x, the function is 7x over s squared plus 2. That is s squared plus 2. Dot, that means we are supposed to multiply, okay, by h of x. And h of x is 2x plus 1 over 3x minus 2. That is 3x minus 2. So here we are multiplying. So with the multiplication, we will multiply the numerators, then we'll divide by the multiplication of the denominators, and that will be all. So 7x will multiply 2x plus 1, then s squared plus 2 will also multiply 3x minus 2. Then we simplify, and that will be all for the multiplication of rational functions. So we have 7x times 2x. Now 7 will multiply 2, and that will give us 14. X times x will give us x squared. Take note that all these 2x, they have a degree or exponent of 1. But x raised to the power 1 is the same as x. That's why the 1 cannot be seen. So we have 1 here, 1 here. And according to the first law of indices, if you have numbers of the same basis or variables of the same basis multiplying, according to indices, when you keep one of the basis constant, you add the exponent together. So when you keep one of the x constant, the exponent here is 1, that here is 1. So 1 plus 1 will give us 2. Then plus 7x times 1 will give us 7x. So we are done with the numerator. Now down here, s squared times 3x will give us 3x cubed. Then s squared times minus 2 will give us minus 2x squared. Then the plus 2 will also multiply everything. So 2 times 3 will give us 6. But don't forget there is an x. Minus 2 times 2 will give us 4. The reason why we have the minus here is because 2 times minus 2 will give us minus 4. So we try to simplify. Up here we have 14x plus 7x. There is nothing we can do about that. Then we look at the like terms. The only cube term we have is 3x cubed. So we leave it like that. Then the only s squared term is also okay. So minus 2s squared. The only x term is 6x, and the only constant is 4. So when we multiply g of x by h of x, that is the answer. When we multiply g of x by h of x, that is the answer we are getting. I guess you understand that. So with the multiplication of rational functions, we multiply the numerators, then we divide by the multiplication of the denominators, and that will be all. So finally, we are looking at how to simplify division of rational functions. Division of rational functions. So I guess you understand what's really happening here. This is multiplication of rational functions, and with the multiplications, we multiply the numerators, then we also multiply the denominators, and then we simplify, and the answer will be out. So we continue with the division of polynomials. We continue with the division of polynomials. So in general, that is what we mean by the operations on rational functions. Now, g of x divided by h of x. Now, this is the g of x function is 7x over s squared plus 2, given in the question, divided by h of x, and h of x is 2x plus 1 over 3x minus 2. That is 3x minus 2. Okay, so this one is the same as now. Do you know that when you have 2 over 3 divided by, you have 4 over 7. Take note that when the division sign changes to multiplication, 7 will go up and the 4 will come down. So we are applying the same principle also here. So we have 7x over x squared plus 2. Then when this division sign changes to multiplication, don't forget that 3x minus 2 will now be up here. Then the 2x plus 1 will now be down here. Then we simplify. So when we do that, then we are back to the multiplication of rational functions. And we know that with the multiplication, we multiply the numerators. That is 7x by 7x minus 2. You make sure you keep them in brackets so that it will not affect the answer. Then we also multiply x squared plus 2 by 2x plus 1. So this one is also multiplication. And you can simplify that. So 7x times 3x will give us 21x squared. Then 7x times minus 2 will give us minus 14x. So we are done with the numerator. Then x squared times 2x will give us 2x cubed. Then x squared times 1 will give us x squared. Then 2 times 2x will give us 4x. Then 2 times 1 will give us 2. So we simplify. So that is the answer. So we have 21x squared minus 14x divided by 2x cubed plus x squared plus 4x plus 2. So that will be the expression. Now, in general, with the division of polynomial, the division sign will change to multiplication. And when we do that, take note that it was 7x divided by x squared plus 2 divided by 2x plus 1 over 3x minus 2. So when the division sign changes to multiplication, then the 3x minus 2 goes up and the 2x plus 1 comes down. Then we simplify. We multiply the numerators divided by the multiplication of the denominators. And by simplifying, the final answer will be out. So in general, when we talk about operation on rational functions, the additions, the subtractions, multiplication and divisions, that is how it goes. That is how it goes. Now, that will be all for now on this particular episode. I'll meet you in the next class. Thank you.